An important aspect of sex in its various guises is the separation of alleles from one another. In an organism that is obligately sexual, typically you'll find a greater inability of sex to separate alleles. That is, the alleles will display linkage if they are physically closer together within a chromosome. In fact, here we have two alleles, A and B. It is difficult for a recombination event to, in fact, separate those alleles because the alleles are so close together. Here we see the two alleles on a eukaryotic chromosome instead of a bacterial chromosome. In the absence of sex, however, all alleles are linked together. So it doesn't matter how far apart they are. If there is no sexual recombination process going on in a population, then the alleles will not be separated. They'll remain linked together within a genome. And this is true whether it's a bacterial chromosome with the alleles widely separated, or instead eukaryotic chromosomes, indeed with the alleles not even on the same chromosome. We're used to thinking that two alleles that are two loci that are not found on the same chromosome are unlinked. They don't display linkage, but in the absence of sex, they in fact do display linkage. And the consequence of this is that in purely clonal populations, what you end up with is selection acting on the genotype as a whole rather than on necessarily on individual alleles.